Finishing up our 8.4, 8.6 review, we're going to do number 9, which really is involving solving logarithmic equations. We're always going to have to check for extraneous solutions, see if our answer works. But in all truth, you're always going to do one of two things. Either you'll make a log circle, or you'll set the insides of two logs equal to each other. For A, you don't have a log equals a number, you have a log equals a log. You have the same base, so set the insides equal to each other. I'm going to subtract an x from both sides, and I really have 1 is equal to x minus 5. If I add a 5 to both sides, 1 plus 5 will get you 6. Now, of course, what you really need to do is just check if it's okay to plug in x equals 6. Inside here, this x plus 1, 6 plus 1 is something positive. 2 times 6 minus 5, that's 12 minus 5. That's also something positive. That's honestly all you have to do to do a check. The big concern is that your answer might be substituted in, and you might arrive actually with a negative inside of a log. To go to B, do a log circle. We're going to rewrite this as 3 to the second equals 4x minus 5. And of course, 3 to the second is actually a 9. So we have 9 is equal to 4x minus 5. I will add a 5 to both sides, get 14. And continuing up here, if I divide by 4, we could either get a decimal or a fraction. If you have a fraction, though, you have to reduce. If you just divided 14 divided by 4, you'd get 3.5. And of course, the big question is it okay to plug in 3.5 inside of this log? You might want to look at the inside. It's 4 times x. It's 4 times 3.5, and then minus a 5. If this is positive, we're okay, and it is. Again, if we would have had a negative value inside, we'd actually have to say there'd be no solution. For part C, set the insides of these logs equal to each other. We wouldn't be doing a log circle here. Subtract a 2x, and you can see we have negative 5 is equal to 2x minus a 9. And if we were to go ahead and just solve by adding a 9 to both sides, negative 5 plus 9 is 4. 4 is equal to 2x. I'll divide by a 2, and I'll get an answer of x equals 2. The big question, however, isn't whether x has a positive value, but more to the point, when I plug that in, will I get a negative inside of the log? 2 times 2 minus 5 is actually going to get you a negative 1. Look at that. 2 times 2 is 4. 4 minus 5 is negative 1. If we tried to take the log of something negative, the calculator says, hey, you can't do that. This answer is no solution. Despite having a positive answer of x equals 2 when we solved, we're actually going to see that it doesn't work. And when your answer doesn't work, we have to just say no solution. The last part, for D, when you're adding two logs, the property that we saw earlier was that you may condense those two logs into one by multiplying their inside parts, called their arguments. So we'd have the log of x times 20. Of course, x times 20 is 20x. Of course, anytime you have log without a number written out for the base, it is understood to be base 10. Well, right now we're going to go and finish this problem by making a log circle. We'll have 10 to the second is equal to 20x. 10 to the second is 100. And when I divide by 20, I will have 5. And once again, the ongoing question is it okay to plug in a 5? This is the only log that has an x in it, and having a 5 would be okay. We'd have a positive value. So that is our answer. And with that, we're done with this review.